So today I'm going to tell you a little bit about the technology, and then it's basically a four-step trip. We're going to talk about a functional testing capability, as you'll see some examples of that. Now, AJAX, asynchronous JavaScript and XML, introduces a new twist of complexity into functional testing because the interaction between the client and the server is asynchronous. That's why it's called AJAX. So we'll spend a few moments discussing how eValid handles AJAX. Once a functional test has been perfected, including the case where it's an AJAX application, it can be put into monitoring mode, which basically means running it continuously in order to collect data about the relative performance of an application, a web application over time. And then a major development with eValid, a major feature of eValid, is that the engine can be scaled up, playbacks can be scaled up with the simple expedient of running multiple browsers, and you'll see how that works. We're going to do a simple example and one that does will be a mind-bending example with 100 playbacks simultaneously. So first off, the technology. By the way, the product that you see right here, this is the eValid engine that you see. This is version 9, build 291, and it is a browser. So if I go to Images or I go to Maps on Google Maps, come back, thank you Google Maps, wherever I want to go, this thing behaves as a browser. What we did was we used the Microsoft IE 5.50 and later Trident rendering engine, and that's a C++ collection of libraries, and we did a classic software engineering trick of overloading those libraries to build this particular browser. This is all built in VS 2008, Visual Studio 2008. That means that this product is self-contained and efficient, and it is optimized for testing browser applications. It does have some capability for testing application mode and desktop mode, so it is able to work on the desktop, but it's primarily optimized for browser apps. Because it's implemented as a Windows product, a Windows program basically, it has very low overhead, and an important characteristic of eValid is that the the results that eValid accomplishes are not done by messing around with JavaScript. So we do not interfere with the JavaScript engine, which has some security limitations. Being the browser, eValid, that is, speaking anthropomorphically here, eValid doesn't have to worry about that because it is the browser. As you'll see here, I'm going to just do a simple test. You'll see that all the interfaces are text files. Here's a script I recorded earlier, which is just and I can play that back because what that will do is go to the same page I'm on, and you'll see that the script file is very simple. There are keywords with modifiers that are pretty straightforward, and the log files that are produced are also text files, and this is in keeping with our basic idea with eValid to KISS, keep it simple. I forget what the other S stands for, but superiorly simple, I suppose. Simple. In any case, we've got an engine that has a lot of features, and I'll just go through. I'm not going to expect you to understand all these menus, but we have our own, some things like File, View, Go, and Favorites are all standard. We have some things added to the Tools menu, Find, and EV Manager, Image Diff, and EV Interactive. In recording, we can start and control a recording, stop recording, insert a recording in the middle. And then here, I'll just go through the menus so you get a sense of what these pull-downs are. 99% of what you're going to want to do in the creation of a functional test of a web application, 99% of that is done from the GUI. And then there's playback, and we'll get to a load test. Site analysis is a spider in the browser which exists in the product, but we won't talk about that. That's a subject for another seminar, another webinar. There are lots of settings. As you can see, it's a very robust collection of settings. So recording and playback and handling load, all of these parameters. And I won't modify anything right now. There is a set of windows including log files, and in case anybody is asking, inevitably people ask about this, so I'll say that if you do help documentation, you do get to the version 9 user manual, which because eValid is a browser is online. So let me show you how simple it is to record a test. So if I start recording, and I'll specify in something that doesn't, I want to get past that auto-completion stuff, and I'll look for Google search for 444, and then I'm going to make a validate selected text, and I'll just do that right there, and you see that's going to be that's a kind of a complete test set. On to a certain location, I've typed an input, a stimulus to the web browser. I've followed what happens when I submit that stimulus, and then after the result arrives back, and so what happens as we play it back, eValid will, now it'll delete the cache, delete the cookies, because we want a original state when you started the browser. So sure enough, we get a yellow screen here. Now I'll look at the, I'm just going to look, there are a lot of different logs here and reports, but I'm going to keep it simple today and just look at this one selection. It seems that the location of the text item at ID88 has changed. So eValid has a feature in here called Adaptive King due to minor page changes. And the truth is these web pages change a little bit all the time. If you do any kind of testing of web browser-enabled applications, you'll understand exactly how variable these things can actually be. It's really quite amazing. So what eValid does, index, finds it at 87 rather than 88. Okay? And that's fine. And we get to the bottom and we find that the text matches. But let me show you some more about adaptive playback. I can't change the Google search results, but I can change the script to say, let's say saved instead of save time. So now we know the test is going to not yield a yellow or a green screen. It's going to find an error, and let's just confirm that finding that error actually happens. So we run the test back, and by the way, I've put a ceiling of 3 seconds on all those wait times, and you'll see later on when I multiply the wait time times 0 exactly what happens, and indeed we get a red screen because, now let's look at the event log, down here the phrase saved time was not found anywhere on the page. So eValid first looked to see if it could find save time at the specified index, and that's a document object model index number with a specified offset. Now, while we're looking at this, I want to point out that eValid does know about all the individual timings of all the page components. I've got the detailed timing option turned on. You don't have to have that, but if you do have it, then eValid records not only the download time of every page component that contributes to that particular URL, but also how long each one took. And it records those times here. The total page download was 1.8 seconds. And if you added up all the times here, 1,000, 1,100, if you added those all up, you would find that they total to larger than the elapsed download time. And of course, that's because the browser is multi-threaded, because you've got things that are running in parallel. So I've illustrated here that I can edit a script very easily. Okay. Let me go on now to an example, and I'm just going to use one that's pre-prepared. I hope you'll forgive me. I've learned over the years, don't try to do any, what is it they say when you're quizzing a witness, don't ask the witness any question you're not prepared to hear the answer of. So I'm not trying to do any tests that I haven't seen work before. But here's a very simple test of an Ajax application, and let me just play it back and take a look at it. In Ajax, almost all of the navigation that you do in a page is automatic. eValid knows how to do the automatic navigation. So, for example, we're waiting for that page to show up. But notice that even though the navigation is complete, there's still parts coming down. What happens is that in Ajax, the interrogation relationship between the client page and the server page is pretty sophisticated. And if we look at this event log, I'll go ahead and maximize that so you get a sense of, we got to the command completed right here. We got to the page was complete, but there are still all these items that were still coming down. That's because Ajax, as an active element in that page, the Ajax parts running the JavaScript engine, those parts keep doing things in spite of our best contention. So the real issue is how do we, and let me just illustrate what happens if I take this same test, and I'm going to take this test with a playback delay multiplier of 0, I'm not going to predict what's going to happen. What's going to happen is because eValid isn't waiting at all and the natural page synchronizations aren't sufficient, we'll get a red screen because this won't behave correctly. So we go to the page, and we're getting as you look on the screen, you see that the page synchronization says, okay, the page is complete, but it hasn't finished downloading everything. And we go ahead and we type stuff in. We've typed stuff in, and we get stuff in the wrong place. Because these delay multipliers, let me go over here and show you what happened. When we get waiting 4,500 times 0, well, we eat up 63 milliseconds. By the way, this is the elapsed time of the beginning of the test in individual parts. We multiplied the waiting times 0, and tenth of a second, 100th of a second. That's kind of typical. And sure enough, we get a red screen because things were not done correctly. Now, how do we overcome that? Well, there's a little gadget in our product called the page map. Here's the page map, and basically if I click anywhere on the page map, eValid will show you the document object model properties. I don't know if you're familiar with what the document object model is, but this page is actually composed of, in this case, several hundred. Let's see where we go down here. That's 125. If we go to the bottom of this page, let me go down to the bottom and pick off something down here like this div. It's got 482 elements in it. So this document object model is used by a user to figure out where to synchronize. Now what we did is we also used a set of there's a set of DOM technology resources that are available, and I want to show you what those primitives are. We can go into the DOM and we can read a value and synchronize on a value in the DOM and actually modify, read, write, get, put, the usual collection of things. So this is called structural testing. And what I did with this what we've done with this third example, move 3, I'll open him up and show you what we did, was we converted the input statement, input value, into 2 commands here. Pardon me, 4 commands. Set the index to 0. Go find the local enter a country name in frame number 1. Frames are numbered 0, 1, 2, 3 in terms of the order in which they appear on the screen. And then we go and find the tag name in input, and we drop USA into that tag name. Then we wait a 2.5 seconds. Well, that's going to be a 0 when we play it back. We go find the next item, which is the text field called search, and we we input a value puppy into the search field on that same index, on that same element, and then we input this value the way we did originally. If I play this script back, and I'm going to drop that frame out, if I play this script back, and let me get rid of the page map because it just confuses things. If I play that back, you'll see that this script works. Now here's the natural page synchronization in place. Natural page is waiting for the page document complete, document available, document ready, all of the internal signals to say ready. But then we do an additional synchronization step. We wait for the word a country name to show up on the screen, and then we absolutely type in those things, and we get a perfectly good green screen. If you look at this timing now, that took 21 seconds. And all of these wait times are multiplied by 0. I'm going to play that again just so you see it go by and get a sense of what's going on. Now, our approach here, this may contradict the notion of keep it simple, stupid, but simple there. I didn't say that other S word. I did say it. I shouldn't have. Anyway, this goes a little bit beyond keeping it simple, but these are pretty simple commands to construct once you get the hang of it. There are only about 20 different commands you have to learn, and as you look at this script, you'll see that we know what we're looking for because we're looking for the search, and we know what we're going to type in, the USA, because that was recorded from life. And we know the frame number, but we don't have to look that up. The only thing we really have to look up is on this page, and I'll show you how we did that. I'll bring the page map back up, turn it on. And I looked for that particular element. Whoops. That particular element in this page. Why is it does not working? I think I don't have control. Well, rather than beat on it, I'm just going to See if I can get this to, will the page work? Yeah, there we are. Let me go to the page where that input is and click on it and interacting, and I'm just going to skip that. So let me turn all this off. In any case, what we do is we find the features inside the page that we need by looking at them, looking for them with what I'm going to show you, which is that to prove to you that this is operating inside the DOM, I'm going to run this test minimized. I can turn that thing down like this, and we can watch the app operate perfectly normally without this particular application using the screen at all. So the tests can be run minimized, and that's pretty important. Do it right, I can bring this back up. That's not the right one, it's this one. All right, so I bring it back up. Now, let's go on. If I've got an Ajax application, and just we want to make sure that the playback is desktop safe, because in monitoring mode, you're going to be using the Windows scheduler to talk to a series of batch files, and I'll just run this same test from a batch file. There it is, eValid -b, move3, mon2, EVS, with all of that. And this actually has some additional gadgetries built into it, and I'll show you that in a second. So we're going to be running with a batch file, and we want to make sure that we can run multiple tests, and so we probably in monitoring mode would run these tests minimized so we don't have screen contention, although since we're not really using the desktop screen, that's not really an issue. So any application which requires complicated context, including all of the things you can think of Web 2.0, all of those can be converted into using these structural commands into desktop safe playback. There is, just to be sure, there is a mutex, a lock-unlock mutex if you do have to divide the timeline. There's extensive data collection available, so I'm going to show you what we did with that move3 monitor script. I think it's move3 mon3. I think that's the one. What we did with that was we took the same script and we've added in phrases like elapsed time. No, we've used a save record command to download the times, and we've basically time banded this particular example so that you get a kind of what we call a layer cake chart. So just to say in general, interfaces to reporting engines. I'm going to have Whaley take over the screen. Whaley, are you there?
Okay.
Why don't you take over the screen, and we want to show you an example of the groundwork open source monitoring that's running a banded script. So go ahead and take over the screen, Whaley.
Okay, can everybody see our monitoring page with 4 .evs files?
Yeah, I can see that.
Monitor control? Okay, if I were to click on the first one, you'll note that we get a page which reveals the status of this mondemo.evs file. And if you highlight over it, you'll see the details for this particular run at a given time. Script ended with no errors.
Yeah. So that particular chart shows elapsed time of the various stages of the execution of that particular script. So you want to be aware of where there are gaps. So for some reason there are some gaps in there, but that's what we're doing monitoring for, to identify where there are problems. Currently everything is running okay. Let's see, look at the Google. That one's a little bit more reliable. This is, of course, a demonstration, so we can decide which ones are reliable and which aren't. So, Whaley, go ahead and show the time history of that, of say, the Google. So you can also get the time history by clicking there, and you get, that's the last 5-day average, 5-minute average, and you get the 30-minute average, and go down to the bottom, the longest one we have. And you see that goes back to July of last year, and in October, November, there were some performance degradations. So we've been running that script continuously for that length of time. Okay? All right, well, thank you very much, Whaley. Why don't you give me back the screen, okay?
Okay.
Now what I'm going to do, show my screen, and there we are. Now, we go to server loading. And the idea of server loading in eValid is we can replicate browsers In fact, we can run hundreds of instances. We'll show you in a moment. There's a special version of eValid that minimizes the footprint of the product. The reason we minimize the footprint is because in server loading, the resource you run out of first is RAM. On a 3 gigabyte typical 2 point something or other megahertz Pentium 4 with Vista, you get 100%. You get about 100 browsers, and for some larger machines, you get larger numbers. The idea of running an emulated user, which is 100% real user, is that you actually collect real experience. The server does not know that they're not seeing 100 simultaneous users. I won't spend time on it today, but there is a virtual user emulator, VUs, with a thing called eValid, and that's based on using the HTTP protocol capture from the test, but we don't really rely on that for much except to generate head traffic on the target server. There's a very low playback overhead, and there is a simple scenario editor. So I'm going to go in and locate the scenario editor right there. And I'm going to say, okay, I'm going to type in the script, which is going to be moo3.evs. Well, I'm going to use that one because we know that's indexed motion structural commands. And I'm going to run this test, just repeating it twice. I'm going to repeat those tests, not 52, Edward, twice, please. And now I'm going to say I'm going to run it 5 times. So I'm pointing and clicking now and creating a scenario. This is a loading scenario that says I want to simulate 5 users. They'll all be 5 users all doing the same thing. They could all be doing something different. It's just a lot easier for webinar time illustrations to show all those. And now I'm going to save that EVL script into the script file. And the script file now contains, I don't need this editor, I can bring it back if I want, but I don't need them any longer. The script file is the same format, an eVal script, eValid load script, is the same format as a regular eValid script, except that an eVal script has one command that can be done that the other form of playback can't, and that's _eValid. And what _eValid says to eValid, the parent eValid, which is the one I have on the screen, is launch an eValid instance running moo3, repeat it twice, and use a playback multiplier of 1, because those are command line switches. In fact, the interface between the parent and the master and the agent playbacks is a batch interface in the Windows environment. And I'm just going to run this, and we'll just see what happens. So remember what I'm doing. I'm going to run this, and I'm not going to save that prior one. And you see eValid launching these 5 instances. And if I can, I'll just when they show up, I'll try to tile them manually, so you can see them. I tried the auto tiling, but because of the fact that I'm running multiple screens, you get into a little bit of trouble with that. So I'm just going to move these guys away as they pop up. So here are my moo instances, and the load test is starting, and I should be able to get this thing to show up. You can see them running. The load test monitor is slow to come up for some reason. I don't know why. But now you see all these instances running. There are 5 of them now running in parallel. And I don't seem to have, there we are. Now I've got the load test monitor. I've requested a total of 10 playback, that's my run count, and I've got 4 completed, now 5 completed. And this little report shows you the min, max, and average playback time. Now, you've got a scenario where you have a script which behaves like a user, and the simplest thing to measure, there are more complicated things that can be measured, but the simplest to measure is the total playback time. And so what we've done is we've measured automatically the total playback time, and I'll wait till that picture shows up. But there's the total playback time for this particular script, and it took between 15 and 29 seconds to run. Now, why is there that variation? And the answer is this particular application, we're beating pretty hard on AjaxDaddy.com's website. We just use that one because we know from experience it has relatively limited capacity. There's a chart that you get that looks like this thing. This is the load test chart. And this shows for each of these tracks. We call that a track. So this is a 5 by 2 5 wide by 2 deep track, and this records the slowest and the fastest times and the average. Now, of course, if there's only 2, then the upper is the faster and that's the lower, but if there are 20, and there's no limit, if there are 20 of these tests, then you could do those pretty easily. And you could group these by, now if I go back to the scenario editor, if I open EVL, the load test, that'll bring up the scenario editor. If I gave them, by default, they're all different identifiers, but if I assigned them all the same identifier, then I would be grouping the data in a slightly different way and you get just one chart. So there's a lot of flexibility and a lot of options available. Now, I'm going to switch. Whaley, why don't you grab the machine, and you're going to show us an example that we've concocted that shows 100 simultaneous browsers running. So go ahead and show us that example with 100 eValid browsers.
Okay. Waiting for things to load right now.
I don't see your screen.
Show my screen. Yeah, I got to click to show my screen. One moment.
You got to show your screen. I don't see your screen. That's why it's good to have 2 of us.
Okay, do you see my screen yet?
I don't see your screen yet.
No,
now I see your screen.
Okay,
so we're
you know,
loading.
There's 100 eValid browsers on the desktop. I'm going to put them side by side.
See right down
now.
there, yeah, right down there on the bottom. You see where you have 100, and now we're going to tile them. And this will take a second or 2 to come up.
Okay.
Where are they all?
No, there's a
Oh,
10-second
there we are.
delay between.
There's a Citrix delay in the broadcast here. So now you have all of these things running, and each little box, currently they're stopped. We're going to go ahead and start them all, okay? So Whaley, click the button that says Start Them All. And just so you know, the way we're synchronizing this is that each script is looking at that particular page and seeing if it sees the words running. If it sees the word running, and we've stylized it with the underscores so that it's unmistakable, when each script sees the word running, it goes ahead and starts to run. So there's a mechanism we have here for launching all 100 of these simultaneously. And so they're running. Can we maybe look at the load test monitor, Whaley? Can you bring that up?
I have to fight this screen. Let me see.
Yeah, well, and this particular script, what the script is doing is downloading, just so you know what it's doing, is downloading a 1 kilobyte file. And we use this kind of a test to measure overall capacity out of the server by downloading that particular file. And it would be nice if we could see the load test scenario with the column of 100 entries.
Yeah, I can't gain control of it right now because it's.
You can't, because we
Honestly, it's
saturated
busy.
this machine. Yeah.
Right.
One of the things, while we're watching this, I'll just comment. One of the things we found is that the Windows operating system is a very good operating system, but if you're running 100 eValid browsers all competing for the CPU, there's little else that CPU is going to do. As I say, we run out of RAM first and CPU second. Sometimes, depending on the script, you run out of a whole bunch of other resources. I guess these are now finishing. Some of them are dropping away. So we'll just keep on watching the screen as they drop away. And then, of course, I want to look at the load test scenario. Now they're all done?
Yes.
Okay, let's look at the load test monitor. And we see what that took. The times involved were anywhere between 40 and 121 seconds. And now, since I know which server we're running on, we're running the eValid server, and we know now something about the load that's imposed. When you have a lot of people asking for that same kilobyte file, the download time increases, in this case, by a factor of about 5. So here's the variation in time in the load test chart for 100 simultaneous users. Okay? Okay, so screen comes back to me. And let me now, I'm at about 35 minutes in, and let me try to summarize. Let me show my screen. I'll summarize what it was we've seen. And what I've tried to get across is that we have a very self-contained, efficient, scalable test engine that can apply to literally any kind of web browser-enabled applications, and in particular those which are AJAX or Web 2.0, where there's a lot of simultaneous communication between the client browser and the server. And we can test all of those for validity and make our tests robust so that they don't fail when minor changes occur. This way you keep your investment in your test suite because they don't fall apart as a result of simple page changes. And at the same time, this is an engine which can be used for monitoring, to measure response times over time linearly, days, weeks, months. I guess we had an example there that was 7 months or so, 8 months. Or this is an engine that can be used to measure response time in parallel simultaneously, imagining that you have 100 or 200, or if you use multiple machines, 500 or 1,000 browsers all running in parallel. So we think it's a very straightforward, very clean, a suite solution that has a great deal of flexibility and capability.